Hello, Math 30. Hope you guys have a good volleyball weekend. We are here working hard on lesson 6, and the notes that you have from Mr. Zotner are going to be completed as we do the screencast. As you can see in the background, that we're going to be dealing with radical and rational equations, and some of these equations we're going to do algebraically, and they might result in extraneous roots, but we're also going to solve them graphically, and that might involve having to see x-intercepts or zeros, right? Graphically, the extraneous roots, when you look at graphically, they don't show up. You won't see them because they're extraneous, and what you see is what you get when you graph it, right? Graphical solutions may sometimes give us approximate answers. And what that is saying is that if the answer to a question is x equals root 2, it's not possible for a calculator to come up with that exact value. Your calculator is going to give you 1.4 or something rather. So that's the limitation of a calculator, is that it can't give you exact answers. So for Math 10, rational equations, not Math 10, Math 20, sorry. Math 20, we did some rational equations, and the steps that are followed there. So the first thing I need to do is I need to factor. And if I factor this, I get 8 over x plus 4 times x minus 4. Plus 1 is equal to 1 over x minus 4. I have to consider the lowest common denominator. And the lowest common denominator here is x plus 4 and x minus 4. Now what Mr. K begged you to do in Math 20 was, when you clear denominators, blow them up. You're supposed to put them beside each of the terms so that we can see what happens. So I multiply the lowest common denominator by every term, which seems like... So once you've put it beside each term, you can quickly see that, I love it, because that blows up. Nothing blows up there, but that blows up here. And as you look at your new equation that's no longer rational, you can see that my new equation is 8 plus, in this case that multiplies out, plus x squared minus 16 is equal to x plus 4. And now I have a quadratic equation that I'll take all to one side. We'll blame this on Nick. Nick forgot that we were supposed to put, after we factor it, we're supposed to put the non-permissible values. So at the very beginning, we make a statement, x cannot be equal to 4 or negative 4. Those are the non-permissible values. And so therefore, when we look at the end, we got our quad, we factored it, we got answers, and now we know that this answer cannot be here because x is not allowed to be 4. And that is an extraneous root. Now the question says that we should verify our answer, and if you actually do, check your answer that you do have left. If we check negative 3, when you plug that in there, you get 8 over minus 7. Plus 1 is supposed to be 1 over minus 7. So if you plug it back into the original equation, and that ends up being minus 1 over 7 is equal to minus 1 over 7. And that makes us happy because it does check out. Okay? Okay, so we're solving it. If you look at this equation, it's actually the same equation as before. And now we're just going to do it without using algebra. We're going to use graphing. So we're going to decide on which strategy. In this case, we're going to try both out. We're test driving both. One of them is called using zeros, where you solve the equation for 0. And method B is where you find the intersection. And you might be clear on that, but we'll make sure we are. The first thing you want to do is you want to state the equations that you're graphing. So you have to tell the person, what did I graph? Second thing you'll do is you'll state the window that you graphed it in, and then you'll state where are the solutions based on your method, and lastly you'll just state the solution. So in option A, zeros, I take that equation and I take it all to one side. So it's called making the equation 0. So when we do method A, I solve the question for 0. I'm going to just see where I have room. I have room under here. I solve the question for 0 and I say, okay, so part one, make the equation equals 0, right? You make the equation 0. So therefore, what am I going to do? I'm graphing y1 equal to, now if you take it all to one side, if you just look at what I was trying to say there, if I took this all to one side, I would have 8 over x squared minus 16 plus 1 minus 1 over x minus 4, okay? If I took it all to one side, that's what I would have. I just took that one little piece and I brought it over there, okay? So when I solve this graphically, I make a little statement. I graphed y1 equal to 8 over x squared minus 16 plus 1 minus 1 over x minus 4. I graphed y1 equal to that, and I state the window in, and because I don't want to write too much, in an SW window. And if you remember, that was called a standard window. That's the one in your calculator that's 10 by 10. And if that works, then use it. If it doesn't work because it's not big enough, then you'll have to change it. I want you to graph that now in your calculator and then come back and we'll talk and look at it, okay? All right, so now you've played with the graph. You guys have graphed y1 equal to that. You took it all to one side, and you should have got a picture like the one on the graph. Draw that in your space in your notes. The trick is, where's my answer? We know that my answer was -3. Turns out that because you've taken it and made the equation equal to 0, the solution graphically is the x-intercept, or where y equals 0. And the only place that y equals 0, as you can see in the picture, is at an x value of -3. So you need to make all these statements. You need to say, what did I graph? What window was it in? Where are my solutions? They are the x-intercepts of the graph. And lastly, you tell me that my answer is -3. In the second method, it's called the intersect method, you are graphing the left side and right side of the equation. When you do that, you're going to get two graphs. And it turns out that the solution is where this half, or this graph y1, is equal to this graph y2. So where those two graphs intersect is the place of your solution. You're only interested in the x value though. So I want you to graph it, draw a picture, and see if you can see the solution. And come back and look at the note. All right, in the second method, you guys graphed it, and now if you notice, it's really challenging to try and see the graphs, and as we found here in class, your graphing calculator, it ends up being just a mess. But if you look at the blue one, which is y1, and the red one, which is y2, there is only one place where they intersect. And the clear thing you must state in your solution is, I graphed y1, y2 in a standard window, and this statement right here needs to be made very clear. The solutions are the x values of the points of intersection. It would be considered a partial answer if you said it's just the points of intersection, because you're not interested in the y values. Therefore, the answer is simply just x equals 3, because that's the x value of that point of intersection. On the next slide, you guys are supposed to solve this graphically and then check it algebraically. So when you do it graphically, just do it one method. You don't need to do both. Try it one way and see how it turns out, and then check your work algebraically. All right? Okay, so we finished this algebraically. One of the things that me forgot to do again was, I noticed that I put that asymptote as you did the graph, but we should be at the very beginning stating x cannot be equal to, in this case, x cannot be equal to 3 over 2, or 1.5. So there's that asymptote. You should have got two answers by using your calculator of -0.43 and 3.10. Those are not exact, okay? And you have to, for a complete solution, put down what you graphed, what window. The answers are the zeros, and those are the answers that should work, but they're approximate. The algebra will set you free, and if you do this algebraically, you can go back up to the original equation, and as I put up there, you can cross multiply and come up with an algebraic solution, which I'm going to do right now. All right, so this unit is about doing it algebraically and graphically. Graphically gave us these answers, which are fine, but as these wise math students in class realize, that's only approximate answers and they aren't precise. When you do it algebraically to check yourself, you find out that you get a quad equation that does not factor. When you cross multiply and do it algebraically, from Math 20 we know the quad formula and we use it to come up with exact answers, and those are the answers to 2 decimal places. But this is much more powerful because it's exact. The final actual answer, if somebody was really looking for simplified answers, would be x equals 4 plus or minus 2 root 7 over 3. Wasn't asking for that, but that's just math fun. Okay, continue on, look at the instructions. This again is from Math 20. We did some algebra from Math 20. Those are the steps. Follow the steps that we did in Math 20, and let's algebraically solve that radical. Away you go. Okay, so if you follow the instructions that are here, restrictions are that the radicand must be greater than 0. So that means x plus 4 must be greater than or equal to 0. So your restriction is that x must be greater than or equal to negative 4. If you isolate the radical, that means you've got root x plus 4 equals x plus 4. Take the 2 to the other side, square both sides, and you end up with x plus 4 equals x squared plus 8x plus 16. When you take it to one side, you end up with 0 equals x squared plus 7x and plus 12. That gives us 0 is equal to x plus 4 and x plus 3. So algebraically, we have solutions that are x equal to minus 4 or x equals minus 3. We check to see whether that conflicts with our answers, and x greater than or equal to negative 4. So far, both of those answers work, but we're supposed to check to make sure that they're actually true. Okay, so if you followed through, you found your answers, and when you check each one to verify, which you need to do with radicals, you'll find that both of those answers have good solutions or are actual solutions that can be verified. If you go to the next page, you'll find that it's just there's nothing to work to do, but it's just another version of what we talked about before, about the different methods of graphing. I want you to finish off the last example, and then the assignment is on a worksheet to follow, and I will give you the solution to example 2 in a minute after you've looked at the next page and you've tried example 2. All right, this is the finishing touches to this lesson, and so if you solve this algebraically, it works great, better than graphing, except for you'll notice that you have to make sure that you check your final answers. So if you isolate the radicals, square both sides, you get answers of negative 12 and 5. And when you check those answers on the blue on the side here, you'll notice that for x equals 5, you get 7 equal to 1, and clearly that's not true. X equals 5 is an extraneous root that does not work. Please complete the assignment that Mr. Zotner gave you, or the worksheets on 124 to 128, 1 to 8, and please follow the instructions. There are questions that I've written to do algebraically and some that were written to do graphing, okay? And use the key things for full marks that we talked about in this lesson. Good job, you guys, and have a good weekend.